Hello everyone. Today I am sharing with you how to use prime factorization to find answers for highest common factor. Before we move on to that, allow me to share with you some common words, some common terms. First one, natural numbers. Now what are natural numbers? Natural numbers are counting numbers. Example 1, 2, 3, 4, and so on. They are ordinal numbers and they are counting numbers. Okay, we are very familiar with since primary 1. All right, and the largest number is actually endless. It's called infinity. Now, what are whole numbers? Right, whole numbers seems easy to all of us, but actually there's something into it. Right? The detailed meaning. So what are whole numbers? Whole numbers are natural numbers, including zero. Earlier, in our previous slide, we know that natural numbers exclude zero. It starts from 1. But whole numbers starts from 0. So what are whole numbers? Example, 0, 1, 2, 3, and so on, up to infinity. Now, what are prime numbers? Prime numbers are important numbers when we do prime factorization. So it's a very important abstract concept that are introduced in secondary school. But I believe some of you already know what are prime numbers in primary 5 and 6. Now, what are prime numbers? Prime numbers must fulfill two rules, two criteria. Rule number 1, a prime number is a natural number. It can be divided by itself and 1. So it can only be divided by itself and 1. For example, 2, 3, 5, 7, and so on. Now, 4 is not a prime number because 4 can be divided by 2 and 1. Okay, 12 is not a prime number because 12 can be divided by 6, by 2, of course by 12 itself. Okay, so remember, a prime number can only be divided by itself and by number 1, leaving behind remainder 0. Now, rule number 2, a prime number has only two factors, right? 1 and the prime number itself. So for example, factors of 13 are 1 and 13. Factors of 3 are 1 and 3. Factors of 19 are 1 and 19. But factors of 14 are 1, 2, 7, and 14. So 14 is not a prime number. So a prime number has only two factors, 1 and itself. Okay, now I'm going to start going through common factors, something that you have learned in primary school. Now, I believe all of you encountered this term common factors in P4. Right? You know about this in P4. So in P4, our teacher taught us to do common factors in this manner by listing the factors of 40 and we list the factors of 64. Then we will find the common factors. Okay, let's try to do this slowly. Let's do 40 first. So 40 comes from 1 times 40. That's one pair or one set. 2 times 20. Okay, all right. And then we have 4 times 10. And then 5 times 8. Remember, we skip number 3 because when we use number 3, or rather, when we take 40 divided by 3, it gives us a remainder. Factors are numbers that are natural numbers. It cannot have decimals, it cannot be fractions. Okay, so when we take 40 divided by 3, it gives us a remainder. So 3 is not a factor of 40. Okay, what about 64? 64, we can have 1 times 64, 2 times 32, 4 times 16. Now, 3 is omitted because 64 divided by 3 gives us a quotient with a remainder. So 3 is not a factor of 64. Okay, now 5 is definitely not a factor. 6, yes. So 6, oh no, 6 is not a factor because 6 will also give us a remainder when we do division. So the final factor that we have is, of course, 8 itself. 8 times 8 is 64. Alright, now 40, the number 40 has 8 factors. The number 64 has also 8 factors. So we have done question A, we have two lists. One list of factors of 40 and another list of factors of 64. Right? Now, let's move on to part B. We want to know the common factors. Common factors of 40 and 63. So let's circle the common ones. 40 has a 1, 64 has a 1, 2, 2, 4, and 4, 8, and 8. I think that's about all. So what is part B? The common factors of both 40 and 63 are 1, 2, 4, and 8. So part B is done. Now, what about part C? Part C asks for the greatest common factor, the biggest of all from part B. That means we use the least in part B to get the greatest common factor. Only one number. So it's 8. 8 is the greatest common factor of 40 and 64. Alright, I think all of you should find this very familiar. We did this in primary school. Okay, now today, the next slide, I will move on to show you common factors using secondary school method. It is the same question, but this time I'm going to use secondary school method of doing. Okay, now first and foremost, in secondary school, we can still use the same way of listing, all right? But we can also use another way, which is called the repeated division way. Now, this repeated division is something similar to what you have learned in primary school, but the symbol is used in the opposite way. Okay, let me illustrate and show you an example. So how to go about using repeated addition. Okay, I'm going to write it down here. Repeated division. Okay, I beg your pardon. Okay, use repeated division method of solving common factors. Okay, so what are the factors of 40? So we write in this manner. 40, we use the upside down division. Now this time we have to use prime numbers to do this question. Okay, now let's use one column to do the listing. Now what are prime numbers? If you refer to my earlier slides, prime numbers are 2, 3, 5, 7, 11, and so on, right? So let's have the first 5 will do. Okay, so first and foremost, let's do division using the first prime number, a 2. So when we take 40 divided by 2, we get 20. Then we notice that 20 can still be divided by 2. So we keep on dividing it by 2. Always start from the first, the smallest prime number. Okay, alright, so we divide by 2 until we get remainder 1, or rather remainder 0. Okay, alright, so 40 divided by 2 gives us 20. 20 divided by 2 gives us 10. 10 divided by 2 gives us 5. Now we are not allowed to have a remainder, right? Because factors cannot have remainder, alright, when we do division. So when we stop at 5, we go down. Okay, we know that 2 is not the divisor anymore. 3 is not a divisor because 5 cannot be divided by 3. 5 cannot be divided by 2. So these two out. Let's move on to the third one, which is a 5. Again, alright, so 5 divided by 5 gives us quotient 1 and remainder 0. Okay, so once we end at quotient 1, when we do repeated division, it will also always end with quotient 1. It must stop at quotient 1. Okay, so quotient 1 tells us that the repeated division way of doing common factors ends. So what are the common factors of 40 using prime factorization? So let me write down for you. 40 is actually equal to 2 times 2 times 2 times 5. Now, how did I get the list of numbers is from here. So 2 times 2 times 2 times 5 is actually 40. And the 40 is expressed in the product of its prime factors. So it's a product of its prime factors. So this is called prime factorization. Okay, so 40 is equals to 2 times 2 times 2 times 5. Okay, now this can further be written as 40 is equals to 2 to the power of 3 times 5. Okay, so this is 40 written in a different way using indices. Right, indices is in another chapter in your secondary 1 book. Okay, now let's move on to the prime factors, the factors of the product of prime factors for the number 64. Okay, all right, so that will be done in my next slide. Okay, let's continue. So just now, let me list again. 40, which what we have done is 2 times 2 times 2 times 5. Okay, now let's do 64. Now, 64, let's do the same way. 64 using repeated division. First prime number. So prime number are 2, 3, 5, 7, and 11, of course. Okay, let's do 2 first. So 64 divided by 2, of course, can be done. Give us a quotient of 32. Okay, all right, and its remainder 0. Right, 32 is a quotient now. So 32 can still be divided by 2. That means 32 can still be factorized. Okay, so 32 divided by 2 gives us 16. Now 16 is the quotient with remainder 0, and it can proceed because 16, 32, 64 are all even numbers. So we can still use the prime number 2 as the divisor. So 16 divided by 2 gives us 8. 8 divided by 2 gives us 4. Okay, now 4 divided by 2, 8 divided by 4, no, sorry, my fault. We cannot use 4, right? Because 4 is not a prime number. So 8 will still be divided by 2 again. That gives us 4. Continue. So when we continue, we are doing something called prime repeated division using prime numbers. Now, okay, I have no more space. I should get the quotient 1. So that's all. Okay. All right. So I have completed my repeated division for 64. So 64, writing in the product of its factors, prime numbers, will be 2 appearing how many times? 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2 times 2. How many already? Okay, one more. Okay, so this can be written as 40 can be written as 2 to the power of 3 times 5. 64 can be written as 2 to the power of 6 because it appears 6 times. It appears 6 times. All right, so yeah, 6 in total here. Okay, so that is called the product of its prime numbers. Okay, so looking at the list of factors of 40 using prime numbers and the list of factors of 64 using prime numbers again, we can do part B. Okay, now part B asks us to find the common ones. Okay, so let's group them. Common, common, common. Oh, no more common. Okay, so what are the common factors of 40? Or rather, what is, okay, this one, right? This circling method help us to find something called, immediately we are finding the HCF. Now, what is HCF? HCF is called the highest common factor. Now, in primary school, we don't call it HCF. We call it the greatest common factor. In my previous slide, you saw it. But HCF, highest common factors, this term is used in secondary school. In primary school, we call it greatest common factor. In secondary school, we call it the highest common factor. So, highest common factor can be easily obtained using the product of prime factors, prime numbers. Okay, so the answer is 2 times 2 times 2, which is 8. And 8 comes from 2 to the power of 3, right? And just now we saw, if you remember my previous slide, the greatest common factor or the highest common factor of 40 and 64 is indeed 8. Okay, now, so this is a summary of what I said just now. The common thing about primary school math and secondary school math is that they both use the common term common factors. But in primary school, when we want to find the greatest common factor, we use the word greatest. But in secondary school, the term changed to highest common factor, HCF. Okay? Right. I hope you can find my video on highest common factor using prime factorization useful to you. Alright, so if it's useful to you, don't forget to give me a like, a thumbs up in my YouTube video. Now, coming up next, I will be sharing with you part 2, how to use prime factorization to find the lowest common multiple. And part 3, involving HCF and LCM, the square roots using prime factorization. And in part 4, cube roots using prime factorization. All these are topics in secondary 1. Okay? Now, if you find my today's sharing useful, how to go about using prime factorization to find the highest common factor, give me a thumbs up, a like. Alright? Kindly drop me comments, because I encourage comments, so that from your comments, I know what you want me to help you, how to go about helping you, and I know that you find any kind of encouragement for me, motivation for me, or even valuable feedback for me to how to make my video even better. Okay? And most importantly, don't forget to subscribe, because when you subscribe, you get to be notified of my future videos being uploaded on YouTube. Thank you for watching my video on using the prime factorization to find answers for highest common factor, which is known as HCF. If you find this useful, don't forget to like my video. Alright, now this is Joseph from Joseph Math Academy, and thank you for following me. Thank you for watching. Goodbye for now. Take care.